Hi guys, it's your boy Jbog back and active. Welcome to Semantic Series. So in this video, I'm going to be teaching you about the history of atom, the discovery of proton, electron, and atomic models. So before we continue, I just want you to know that atom was brought out from a Greek word called atomos, which means uncuttable in Greek. And a lot of people have different perspective of an atom. There's this man called Democritus that he brought out an hypothesis about atom that when you divide a material, when you divide an original material, there's a part at which you are going to divide that material. There's a point you reach, you won't be able to divide it any longer. And that point you reach is going to have the properties of the original material. So what we're just trying to say is that an atom is indivisible and the atom has the properties of the original material. So and a lot of people, a lot of things, everything is made up of an atom. So Democritus, also known as the laughing philosopher, also said matter is the beginning of everything and everything is made up of matter and matter is made up of atom. Although this hypothesis was discredited and rejected by the famous philosopher Aristotle. So Democritus was not actually taken serious because a lot of philosophers are not like taken serious, unlike scientists when they bring out their own observations. So philosophers are not taking. That's why it took a long time before Democritus was actually given credit for his hypothesis and for his saying. So after Democritus, there comes a British scientist, a British school teacher called John Dalton. He brought out the atomic theory that said all matter made up of atom can neither be created nor destroyed. An atom of same element are alike and have the same mass and chemical properties. It also said atoms combine in simple whole number ratio. So he brought out the atomic theory. Of course, he's a scientist. He was given the credit. He brought out his explanations and he brought out. It was recorded that he gave the atomic theory because he was a scientist. So we all know modern atomic theory has nullified some of Dalton's atomic theory. Like when he said atom is indivisible. Atom is divided and they are made up of proton, electron, and neutron. So if you can't divide atom, how come do we have the fundamental particles in atom? So it nullified that. He also said atom can either be created or destroyed. Of course, we can create some certain atoms using radioactivity, artificial transmutation, and you know radioactivity discredited that because when you when you pass a radiation into an element, it gives birth to another kind of element and even some other particles. So it is also discredited that. And he also said atoms of same element are alike in all aspects and have the same mass. This was nullified by the discovery of isotopes because isotopes are elements that have the same element, they have same proton number, but they have different mass number. And what's making their mass number different is the difference in the number of their neutrons. So that also discredited and nullified the aspect of that atomic theory, saying they are all alike in every aspect. So he also said atoms combine in simple whole number ratio. In organic chemistry, we have giant molecules combining together and giving more giant molecules like sucrose, glucose, protein. There are giant molecules that combine together. So it's not mainly simple number ratio. What Dalton was actually saying is if example if hydrogen, two molecules of hydrogen react with one molecule of oxygen to give water, see carbon react with oxygen to give CO2. He was talking about a simple number ratio, but is not always the case. You understand? So in organic molecules, in organic chemistry, giant molecules combine together to give more giant molecules. So that also nullified Dalton's atomic theory. So having discovered atom, scientists wanted to dig deep and find out what this atom was made of. Because in biology, a cell is made up of organelles. So as they know that something can't exist without having something has to exist before another thing can coexist. Understand? So for there to be an atom, there have to be some fundamental particles in that atom that make up the atom. So they dug deep and they discovered electron. So there's this scientist that discovered electron called William Cook. He discovered electron using a discharge tube. So he lowered the pressure in the discharge tube. He placed the cathode, he placed an anode, and he passed electricity, high voltage electricity into the discharge tube. And he noticed that some ray were actually coming from the cathode and hitting the anode. And he called those rays cathode ray. So those cathode ray were now called electrons. So William Cook actually discovered electron. I know that during the experiment, he used a perforated anode. That's something you should note. He used a perforated anode, and the ray was coming from a cathode ray. So named them cathode ray, which was later called electron. So apart from Democritus, there was also an Indian philosopher that also gave this kind of theory. His name was Akaya Kanad, and he named atom Anu. So during those years, books and a lot of books and a lot of philosophical books were writing atoms as Anu or Atomos. So after the experiment William Cook carried out, he was able to give the characteristics of cathode ray, and he said cathode ray they travel in a straight line. That was proved because whenever you place an opaque object in front of cathode ray, they cast the shadow of the object. That's rectilinear propagation of light. So when you put something in front of a light traveling in a straight line, it casts the object of the light. It casts the shadow of the object. So they also have mass and momentum. How were they able to find that? They placed a light paddle in blocking the passage of the cathode ray and was able to rotate the paddle. So anything that can rotate a paddle must have mass and momentum. Understand? So cathode ray also does not depend is independent of the nature of the material used in the glass, and it also penetrates a small thickness of gold foil and aluminum foil. So that's to show you that cathode ray was very light, and it was very light and even lighter than hydrogen, which was the lightest particle ever discovered back then. And when they also placed cathode ray in an electric field and a magnetic field, they noticed it was deflected. And in an electric field, it was deflected towards the positive terminal of the electric field. That's to show you that cathode ray is actually negative because like charges repel and unlike charges attract. So if it was deflected to the positive terminal of the electric field, it shows you it was actually a negative particle. So cathode ray is negative. So another scientist that also took part in the discovery of an electron is J.J. Thomson. And the significance of what he did in discovering an electron is that he discovered charge to mass ratio of an electron using a cathode ray tube. He was able to do that, and he founded the value of charge to mass ratio. Another scientist was also Harry Millikan. Harry Millikan actually discovered the charge of an electron. He was the guy that discovered the charge of an electron. But just for knowledge sake, it wasn't actually Harry Millikan that discovered the charge of an electron. It was actually a student of Harry Millikan that discovered the charge of an electron. It was a project given to Harry Millikan, and he submitted it to a student as an assignment. I know there's always this serious student that takes his assignments by heart and does it very well. So he was able to to discover the charge of an electron, and was able to find faults in his teacher's project. So he used oil. Harry Millikan actually used water he wanted to test water to discover the charge, but because water was actually evaporating, they were not able to get the exact value because it was difficult to get the exact value. So the students used oil instead of water because oil won't easily evaporate. That's why it's called oil drop experiment. So he presented it to Harry Millikan, and Harry Millikan took the credit because he was done out the project, and it was called oil drop experiment. So he discovered the charge of an electron. Yeah, so after Harry Millikan discovered the charge of an electron, using the value J.J. Thomson was able to get, or the charge to mass ratio, it was actually logical and sensible to get the mass of an electron. So using calculation, they were able to get the mass of an electron, which was 9.11 times 10 raised power minus 31 kilogram. So when they got the mass of an electron, they discovered it to be 2,000, approximately 2,000 times lighter than hydrogen. And hydrogen was the lightest element ever known back then, was the lightest thing they've ever discovered back then. And they noticed that electron was actually lighter than hydrogen, which shows us that it was actually a fundamental particle. So after discovering electron, you know, scientists like have to prove their work, because an atom is actually neutral, and if we've discovered a negative fundamental particle in an atom, there ought to be a positively charged particle that is balancing the negative charge to make the atom neutral. So there has to be something that is actually positive. So they also went into research, and there was this scientist called Goldstein that discovered proton, which is a positively charged particle in an atom. So he discovered proton he also used the exact experiment synonymous to what William Crookes used to discover cathode ray, which was electron. But what he did was like he perforated the cathode, not the anode. So ray came out from the anode part of it, and the ray came out of the anode, and he called those ray anode ray or canal ray, which was also called proton. So Goldstein discovered proton. So the mass of the proton was discovered to be 1.672 times 10 raised to the power minus 27 kilogram. It was heavier than an electron. So they discovered that the mass of a proton is actually heavier than the mass of an electron. And they also discovered that the charge of an electron was equal to the charge of a proton, just that they carry opposite signs. One was positively charged and one was negatively charged, but they had the same value of charge. So that's that on that, on the discovery of electron and discovery of proton. Now, as a scientist, you can't just bring out something, and you can't just bring out a a work or an observation just like a philosopher and just say it and and want everybody to believe. No, you need to prove your work, and it needs to pass through different processes like observation, hypothesis, before experimentation, then before it becomes a law, before it can be accepted generally. So when those guys discovered proton and discovered electron, they had to prove how the atom was actually structured to have the proton and to have the electron. So that's what brought about atomic model. So the first person to bring out an atomic model, the first person recorded to bring out an atomic model was actually J.J. Thomson. So he brought out the atomic model, and the atomic model is called watermelon model or the plum pudding model. So what he said was that the atom is his atom contains a pool of positively charged particles where the negatively charged particles are suspended in it. So it's as if the negatively charged particles are swimming in the positively charged particles. Just like maybe the positively charged particle in a watermelon, considering it as a watermelon, the positively charged particle are the red part of the watermelon, while the negatively charged particle are the seeds in the watermelon. That's why it's called the watermelon model or the plum pudding model. This model was actually discredited by Rutherford, a student of J.J. Thomson. So after passing through the school of J.J. Thomson, after getting knowledge from J.J. Thomson, graduating as his own independent scientist, he came out, he brought his own model, and he said J.J. Thomson model was incorrect. So that's to show you, before you get your own model, before you get your own opinion against your lecturer, please first graduate from his class before you correct your lecturer. So he graduated and he bought his own model and said J. Thompson model was actually incorrect, and he bought his own version of the atomic model. Why they accepted Rutherford's model of an atom compared to the way they accepted J. Thomson was because Rutherford backed up his own explanation with experiments. So when Rutherford brought out his own explanation, he made an experiment called the alpha scattering experiment. What did he do? He took a gold, he hammered it into a gold foil. And the reason he used gold was because gold was malleable. So he used the most malleable metal, which is gold. So he hammered it into a foil, then he bombarded the foil with alpha particles. And he noticed that most of the particles passed through the gold foil. Some were deflected, while few actually rebounded. So what does that mean? It meant that those ones that deflected, since alpha particle is positive, those ones that deflected, those ones that deflected were actually, they actually hit a like charge for them to repel, because since like charges repel and opposite charges attract. Since alpha particle is positive and they deflected, it means they must have hit a positively charged body to get deflected. And that positive charged body is located in the center. And how did you know it was located in the center? Because most of the ones that passed through, most of the alpha particles that passed through, they didn't pass through they didn't pass through the gold foil in the center. You understand what I'm saying? They pass through outside apart from the center. So those ones those ones were not deflected. And he brought out an explanation saying this positively charged body was located in the center of the atom, and it was relatively small compared to the whole atom, showing that the atom is an open space. So he called this concentrated center, this positively concentrated center in the middle of the good foil, he called it nucleus. And he said the nucleus contains the proton and most of the mass of the atom. And that's actually true, because mass of the proton is actually greater than mass of electron. So, and since that side is the heaviest part, it means the nucleus contains the proton. So he was able to bring out his model, and his model was accepted, and they rejected J.J. Thomson's model of atom. Since these scientists have been able to discover and prove why an atom is neutral, because they have same number of protons, same number of electrons, and since they are oppositely charged and balanced, the atom is neutral. Yes, they'll be able to prove that. But one thing they noticed was that the mass of an atom was actually twice the size of a proton. And so they were like, okay, since proton is heavier than electron, and the proton actually the proton actually determines the mass of an atom. But the mass of an atom is still like twice the proton. That means there should be a particle aside from proton and electron that is actually present in the nucleus. So they discovered a neutron. But before that, before they discovered neutron, Rutherford has actually predicted this particle. He predicted it. He proposed that there should be another particle present in that nucleus aside from the proton. So they actually discovered neutron, and that's why Rutherford model was actually one of the best, because he actually predicted. So for you to be able to predict something in your model, it means you are almost perfect. So they predicted electron, he predicted electron Rutherford, and he predicted neutron, and they discovered it. So after discovering neutron, the importance of neutron is just that they prevent the atom from flying around, and they bind the protons. They just bind the protons. Proton is positively charged, is present in the nucleus, and has a charge value of 1.6 times 10 raised to power minus 19 coulomb. Neutron is also present in the nucleus, but it does not have a charge. It is neither positive nor negative. While electron is negatively charged, it is present outside of the nucleus and also has a charge value the same as the proton, but it's just that it is negatively charged. And the proton is heavier than electron. You should also know that. So in my next video, I'm going to be talking about atomic number, mass number, isotopes. So stay tuned, and if you've watched to the end, make sure you hit the like button, you share the video to everyone else, and hit the subscribe button, because we are planning to get to 1,000 subscribers before the end of this month, and you can help us get there. Thank you very much. Thanks for watching Smart Series, and thanks for watching Jacob.